Yeah, I sat out there with my little buddy on my hockey team that's 8th grader and did schoolwork. So
Very good. All right, calculus of the logarithmic function. The derivative of the natural log of x, I told you the other day, do you remember?
Something like
1 over x. Remember that the natural log of x is the same thing as log base e of x. So the question is, what if the base is not e? What if it's not a base of e? Well, the derivative of log base b of x is equal to 1 over x times the natural log of b in the denominator. Okay. You must remember this for your driver's license. You do not need to remember this. Okay. Are you going to get your driver's license, Jacob?
I might just barely pass it, but
Okay.
I can.
It's not like barely, like it's 100% or fail, so.
Oh.
Yep, gotta, yeah, all the derivatives listed, you gotta list each one.
That's what it is.
Well, then you got the rest of the test after that, but yeah.
I know. But
Yep, well, the first thing you'll do on the test, you'll list all the derivatives. Hopefully you can do it. She likes that.
I like
She likes it when I list
thought I was
it.
gonna have to solve stuff like this.
Yeah. Well, you are, I mean, for the rest of
For
the
the
test.
rest of the test, but not for my driver's
Yeah,
license.
not for your driver's license,
I
no.
might pass.
All right.
Haley's first time passing her driver's test.
Oh, we're so proud of you guys. All right, so something I just want to bring your way to help you kind of understand is if we have the natural log of 2x to the fourth, sorry, let me try it again. 2x to the fourth over y cubed quantity squared. Do you remember from last year, this is your review, by the way, Dan's going to put her phone away because she's half a phone addict. The disease has spread to her brother as well.
Oh,
So she's going to drop that 2 and put it in front and say 2 times the natural log of 2x to the fourth over y
Get off
cubed.
your phone.
shut up.
Do you guys remember that? Do you then remember that you could take the logarithm of division and separate it into subtraction? 2 times the natural log of 2x to the fourth minus 2 times the natural log of y cubed. Yes, no? We can even move this further and say, hey, we've got 2 times the natural log of 2 plus 2 times the natural log of x to the fourth minus 2 times the natural log of y cubed. We could separate the 2 from multiplication into addition. And finally, you can move these out front as well and get 2 natural log of 2 plus 8 natural log of x minus 6 natural log of y. So since we don't remember it, I'm going to make it as plain and simple as I can. And it is simply this. If you have the natural log of x cubed, that's the same as 3 natural log of x. If you have the natural log of xy, that's the same as natural log of x plus the natural log of y. If you have the natural log of 3 over w, that's the natural log of 3 minus the natural log of w. Those are the 3 rules that we use with logarithms in calculus. So last year when you did your work with logarithms, the question is, why are we doing this? It is for really this purpose when we take these derivatives. And so I'm going to do this derivative 2 different ways, so you guys can then have a choice for how you're going to operate. And I'm going to first do the chain rule, where I say I have the natural log of u, and then what is u? 1 over x squared, or x to the negative 2. What is the derivative of natural log of u? 1 over u. And the derivative of x to the negative 2, so I'm going to take 1 over u, or 1 over x squared, and multiply it by negative 2 over x cubed. What is 1 over x squared? Just x squared, right? You just multiply by the reciprocal. So we get x squared over 1 times negative 2 over x cubed. What happens? Yeah, so I get negative 2 over x, and that's my derivative.
So wait,
I would never take the derivative that way. I would never do that. Can I show you the way I would do it?
Yes.
And you guys can have choice. You can do what you want. But I think that that's part of mathematics at a higher level, is seeing different opportunities. So I'm not going to take the derivative. I'm just going to rewrite it. I raise the natural log of x to the negative 2. You see that? And then I'm going to rewrite it again. F of x is equal to negative 2 natural log of x. And now I'll take the derivative. What's the derivative of natural log? 1 over x. So it's negative 2 over x.
so did we talk about the derivative of the natural log yesterday?
Today. Today we said that, yep, today we said the derivative of natural log is 1 over x.
Gotcha.
Is that okay?
Yeah.
Okay. Let us then move on. We're going to try a couple more problems. We're going to go a little bit out of order here, okay? But working with the derivative of natural log, here we have, what rule do you think we use here? Quotient rule. So f prime of x is equal to the derivative of the top, which is 1 over x times e to the x. Minus the derivative of the bottom times natural log of x over e to the 2x. What could I factor out of the top?
Yes.
Cancel them out.
So f prime of x is then equal to 1 over x minus natural log of x over e to the x. Can I leave my answer like that?
No.
No, you have a fraction of fraction. You have a complex fraction. So therefore, I'm going to have to multiply the top and bottom by x. And so we're close now. F prime of x is going to be equal to 1 minus x natural log of x over x over e to the x over 1. And I can multiply by the reciprocal, and I get 1 minus x natural log of x over x e to the x. That's my derivative. Not too bad? So I do applaud Jacob in that he's going to work on homework this weekend. I would say you really want to enter Monday, hopefully caught up with just about all of your homework, because again, the test is next week, Thursday. So I want to make sure we're ready for that. Okay. Let's move to the next one. This one looks pretty challenging. As you can see, you have the natural log of x plus 2 to the 4th times x minus 3 to the 10th. And this is going to be very challenging. Don't write this down, because you would have to set up the natural log of u, and on the inside you would have x plus 4 or x plus 2 to the 4th times x minus 3 to the 10th. And then what rule would you need for that? You need the product rule, and then you would need twice chain rule.
Right.
So don't do it. Don't do it. Use what you were told last year, okay? use what you've been told in previous years. I'm going to rewrite this, I forgot the f of x on it, my bad, is equal to the natural log of x plus 2 to the fourth plus, anybody? X minus 3 to 10, good. You may want to guess what we do next. 4 and the 10 out front. So f of x is equal to 4 natural log of x plus 2 plus 10 natural log of x minus 3. Isn't that a lot better?
Yeah.
Yeah. So I can promise you, you're going to get examples like that on your test. And if you want to set up 3 chain rules and a product rule, you go right ahead. But that's the better way, and that's why we did the work last year that we did. So I'm going to set up 2 chain rules here. One is 4 natural log of u, and the other one is 10 natural log of u. On the inside, one is a x plus 2, and the other one is an x minus 3. Jacob, you got it?
Yeah.
So the derivative of x plus 2 is 1. What's the derivative of 4 natural log of u? 4 over u. And the derivative of x minus 3 is 1. The derivative of 10 natural log of u is 10 over u. So all I have is 4 over x plus 2 plus 10 over x minus 3. That's the derivative. Isn't that a lot easier?
Yeah.
Let's move on up. I'm going to change this problem, and I'm going to change it to log base 4 of x to the 5th. You could use the chain rule, or what could you just do right away? Put the 5 up front. So f of x is equal to 5 log base 4 of x. We know that the derivative of natural log of x is 1 over x. If it has a different base, all we do is we still do the 5 over x deal, but then we attach the natural log of the base in the bottom. That's the only difference. See that? All right, we flip it over. Try letter E on your own. Go ahead. Just have the chain rule twice. I have the square root of the natural log. So it starts as a setup as u to the 1/2. See that? And so then on the inside of natural log of 2x minus 1, that's going to require the chain rule again. So the derivative is 2 over 2 times x minus 1. Now as I multiply these together, I can see that the 2's will cancel, and I get 1 over the root of natural log of 2x minus 1 times 2x minus 1. Can you guys tell me what you did? Danny has no idea.
Well, how do you know when, like, you can't just do...
What did you set up first?
First, I did, wait. Oh. I did the 1/2, but then I put it out front. So
That's what I did too.
So then I did 1/2.
Okay.
U.
Got it. Okay, so that's what you did as well. If it was the natural log of the square root of 2x minus 1, then you could put the 1/2 out front. See what I'm saying?
Yeah.
So here's the key. Order of operations, if I plug something in for x, I multiply by 2, I subtract 1, I take the natural log, and at the very end, I square root. So the square root is the thing you have to set up right away. Whereas in this situation, plug something in for x, multiply by 2, subtract 1, square root, and then after you square root, then you natural log. When the last thing is natural log, that's where you can move the 1/2 out front. See the difference?
Yeah.
And that's why this example exists, to show you that. So thank you, that helped me see what you guys were looking at. Everybody better in that scenario?
Yeah.
Okay, all right, so letter F, a couple more here. Everybody see the quotient rule?
Yep.
Let's avoid the quotient rule.
Good.
Help me avoid the quotient rule. What can I do instead?
-5.
Okay,
You see what I mean?
-5, or turn division into
Subtraction.
subtraction.
Right.
The natural log of x minus the natural log of x squared minus 2x plus 4 to the 5th power.
Somebody cooked here.
See that? Danny is right. You
Yeah,
could
I
do -5 and then use, but then you would you would just have addition. Okay? So I just use subtraction instead. What could you do next? Drop the 5. So natural log of x minus 5 natural log of x squared minus 2x plus 4. Good. I hope everybody sees that the derivative of natural log of x is just 1 over x. But for the next one, then I'm going to have to use the chain rule. So I have 5 natural log of u, and I have x squared minus 2x plus 4. What's the derivative of 5 natural log of u? 5 over u. And the derivative of x squared minus 2x plus 4 is 2x minus 2. So f prime of x is equal to the derivative of natural log of x is 1 over x minus, when I multiply those, I get a 10x minus 10 over x squared minus 2x plus 4. When you said seminar, all I could think about is like a seminar like I attend on, like,
No, it's.
we're going to talk about, language and mathematics today,
No, it's like super fun.
Yeah, yours sounds a lot more fun than
Yeah.
my idea of a seminar, so good for you. The fun seminar. Okay, just 2 questions left. We are going to end with the right equation or line, one that we can expect. In this situation, you cannot separate into subtraction because you have a natural log on top and natural log on bottom. So therefore, I must use the quotient rule. This one works out pretty well. It's rather nice. F prime of x is equal to, I take the derivative of the top, which is 5 over x times 4 minus 2 natural log of x plus or minus the derivative of the bottom.
Negative 2 over x.
Negative 2 over x, so I have a positive 2 over x times 5 natural log of x plus 3. And that all sits over the bottom square. Does everybody agree that we, at this point, have a complex fraction?
Yep.
Okay, so in order to alleviate this issue of the complex fraction, I am going to, I see that the bottom denominator will be x for the top, right? So I'm just going to multiply the 5 through, and I get f prime of x is equal to, I have a 20, I have a minus 10 natural log of x, I have a plus 10 natural log of x, and I have a plus 6. That sits over x, which sits over 4 minus 2 natural log of x quantity squared over 1. What happens in the top?
The 10, the natural log cancel out.
The 10 natural logs cancel. You're left with 26. And then when you multiply by the reciprocal, can everybody see that the x and the 4 minus 2 natural log of x squared, that those will join in the denominator together? So x times 4 minus 2 natural log of x quantity squared. Yep, that's my derivative. Works out quite nicely. Really does.
So wait, at the top, how did you get the 5 over x and the 2 over x?
So the derivative of 5 natural log of x is 5 over x. The derivative of 3 is 0.
Oh, okay.
See it? Okay. Last example. If you see write an equation for a line, what 2 things do you need? Slope and a point. We're just given x. X is 0. How do I figure out y? Plug it in. So I have f of 0 is equal to 3e to the 0 plus 0 times the natural log of 1. What is anything to the 0?
0 or 1.
1 times 3? 3. And then 0 times that will be 0. So I have 3 is my y value. How do I find my slope? Take the derivative. What rule will I use to find the derivative of that? If it was 3x e to the 2x, then it's the product rule. But because it's just 3 e to the 2x, chain rule. 3 e to the u and 2x. The derivative of 3 e to the u is 3 e to the u. Derivative of 2x is 2. So f prime of x is, I start out with 6e to the 2x. That's where I'm starting. What rule do I use there? Product rule. The derivative of x is 1 times the natural log of 2x plus 1 plus x times, now I need the derivative of the natural log of 2x plus 1. Chain rule. Natural log of u, 2x plus 1. The derivative of 2x plus 1 is 2. Natural log of u is 1 over u. So I get times 2 over 2x plus 1. The goal of this problem is to write an equation for a line, so don't worry about simplifying anything at all. All I'm going to do is plug in what? 0 for x. And so I have 2, or e to the 0 is 1, times 6 is 6. 2 times 0 is plus 1. What's the natural log of 1? Okay, you're wondering how, right? Number one, you can look at your calculator, type it in, but here's the other way. So here's how I remember it. And this is what I do every time when I think about it, okay? An exponential function looks like that. It goes through the coordinate 0, 1. That means that anything to the 0 power is equal to 1, or e to the 0 is equal to 1. You good with that? If we look at the inverse, which is the logarithmic function, we see that it goes through the coordinate 1, 0. That means that the natural log of 1 is 0. Those are inverse thoughts of each other. So that's how we know the natural log of 1 is 0. Okay? Plus 0 times 2 over 1. So obviously this makes 0, that makes 0. I have 6, the slope is 6. So y is equal to 6x plus 3. That's my equation for my line tangent. There you have it. Exponential and logarithmic used a ton. Really make sure that you know these assignments. Monday really is pretty harmless for the most part. So, you guys got some time to work? We are recording. Do we put out a secret word on the video for that?
Yes.
What secret word? Nope.
For Rosa and Ava and Noah who are missing, and for everybody who's...
Since we're gonna watch The Hobbit tonight, how about we do Bilbo?
Okay.
Bilbo, as in Bilbo
Do they know how to
Baggins.
spell that?
Bilbo is spelled B-I-L-B-O, believe it or not.
Okay.
Do they know how to spell that?
By the way, if you're in class right now, I want you to know that Jacob has a 20-ounce Coca-Cola that he is drinking, along with, is that beef jerky?
No,
This is trail mix, sweet and spicy.
Along
Oh my
with
God,
sweet
so
and
many.
spicy trail mix.
5 ounces.
Danny has moved seats because his breath is that disgusting right now. So.